All right, welcome back to chemistry. We've been talking about nomenclature. Last time we got together, we talked about how to name ionic salts. The nice thing about them is that the elements that you're working with only have one charge. Like lithium can only be a charge of +1, and fluorine can only have a charge of -1. Those can never alter. Remember, we learned that by looking at our periodic table and the columns that they represent. Okay, but now we're going to take what we learned there, like how to figure out charges and how to figure out the numbers of the different elements. We're going to take that same information and we're going to use it to figure out how to do this when elements have multiple charges. Now, when we say multiple charges, what that means is if you look at your periodic table, okay, if you look in the transition metals, and I hope I don't have to reteach you where those are, okay, but they're the guys right here in the middle, okay? These are transition metals, all of this group that's in the middle here, okay? Now, if you look on the top of most of them, not all, okay, there are multiple numbers above each one of the letters. For example, look at Mn. There's a 2, a 3, a 4, a 6, and a 7, okay? That means manganese can have any of those charges, okay? Same thing for like cobalt. You can have, what is that? It looks like a 2 and a 3, okay? Iron can have a 2, a 3, or a 6, okay? So they can have different charges. Now, what we need to be able to do is figure out when to use the different charges and then how to name them. How do we show which element of manganese we're using or which element of iron we're using, okay? And I'm going to show you how to do that here real quick. So, again, just a reminder, it's going to be listed on your periodic table all the different charges that manganese or whatever element you have to be working with can have. So all you need to do is know where to look for that and then go back and show it. Okay. Now, just like last time, I have our table set up. Okay. What we're going to do is we're going to write the first symbol, the second symbol, and then we're going to put the common charge. Remember, we're going to put the type at the bottom, and then we're going to actually write the charge. Okay. So for the first one, okay, let's separate out. We have our metal, manganese. Okay. It's a metal. I'm going to put M in the bottom. Now, it's a metal, but it has multiple charges. So next to the M, I'm going to put in parentheses a letter C. That's a reminder to myself that I need to check to figure out which charge I need to use, and then I need to do something special in the name over here to tell people which one I use, because there's different types of manganese that we could use. Okay, so this is where the arrow really becomes important because it's going to help point out which manganese we're going to use. Okay, I gotta leave that blank for now because I don't know which charge I need to use yet from my list. Okay, the second element is oxygen. That's a nonmetal. So I put an N and an M down here. And I already know oxygen charge. The nonmetal charges aren't going to change. Oxygen is always a -2. Okay, now how do I figure out common charge? How do I figure out the charge of manganese? And what do I put over here? Well, what I need to do now is go back to my original formula. Let's look here. I have MnO. So that means I only have one manganese and I only have one oxygen. So the number of oxygens can't change. So on common charge, I know it has to be a -2. Okay? It has to be a -2 because I only have one oxygen and oxygen has a charge of -2. So then that means I have to have what to oppose that? I have to have a +2. So that means manganese needs to be +2. Now, I look at my common charges. Oh, that's the first one. So I'm using manganese, but I'm using manganese 2. And I show that in my name with a Roman numeral. Okay? I guess I should have, you can kind of tell. Okay? Manganese 2. And that tells people when they go to create this compound or find out what compound I'm using, that there are different charges that manganese can have, and I'm using the one for manganese 2. Okay? Still Mn and O, that hasn't changed for the next one. Okay? It's still Mn, still has multiple charges. Okay? I'm still using oxygen. Oxygen is always a nonmetal and always has a -2. But now I have 2 oxygens. So I don't just put a -2, I put a second -2. And that means I have an overall charge on that side of a -4. Well, if I have a -4 on that side, that means I must have a +4 on the other side. Since I only have one manganese, that means this one manganese has to have a charge of +4. So how would I tell people that I'm using that manganese? In over here, between manganese and oxide, I would put an I and a V, the Roman numeral for 4. Manganese 4 oxide. Okay? Let's do one more. And again, let's do another manganese so you can see that manganese is a really good one to work with because it has all these different charges it can have. Okay, it's still Mn, still a multiple charge. Still don't know it. Okay? Still using oxygen, still a -2, still a nonmetal. How many oxygens do I have? I have 3, so I'm going to put a -2 and a -2, for a total charge on this side of -6. Now, what's going to be my charge of manganese? Well, it has a charge of 6, so do I just automatically put a +6 here? Would that make this right? Unfortunately, it wouldn't. Why not? Because over here, it says that I have 2 manganese as a part of my compound. So this +6 that I need has to actually be divided in half. It has to be a +3 and a +3. Okay, so I'm going to use 2 +3s. Can I do that? Yes, absolutely. Look at my charges. I have manganese can be a 3. So 2 of them, 2 3s makes a +6. And that's where that comes from. So then I put manganese 3 oxide. Manganese 3 oxide. That's the only way manganese 3 and oxygen can bond together. Okay? Now, again, it's real simple. Figure out the charges. Remember, the nonmetals will tell you. Okay? And it's the easy way to do it is to rewrite the charges. Like here, I put O3. Okay, so I put the 3 charges. I put -2, -2, -2. O2, I put -2, -2. And that tells me that I have 2 oxygens. This can't change because it's written here in the formula. That can't change. So therefore, it has to be a +6 for this one. It has to be, assuming it had to be a -6, had to be a -4, and that gives you the ability to look at the other side and figure out what's going on. Okay? If we had to do one the opposite direction, let's say I was going to do, let's see. Let's do iron. Let's do iron 2 oxide. Let's change it up so we're not doing an oxide again. Let's do fluoride. Okay, and I'm making this one up on the spot, so bear with me, okay? So I've got iron 2 fluoride. I need to find the formula for it, okay? So let's write down the parts. I've got iron, Fe, has multiple charges. Draw my arrow, don't know the charge yet. Okay, I've got fluoride, which is F. It's a nonmetal. It always has a charge of -1. Okay, now iron can't be a -1, okay? But I already know the charge it's going to be. How do I know the charge? It's written right here. Iron 2 tells me that I have to use a +2. Okay, so what's the common charge? Oh, I've got 1 minute. What's the common charge here? I would need a +2, so I would need a -2 on the opposite side. I can get that by adding one extra fluoride. That'd be plus or -2. So it would just be FO, excuse me, I'm getting flustered here. Sorry. It'd be FeF2.